In this tutorial, we're going to talk about normalizing things in LaserBoy. So, first I'm going to create a little test scenario where, okay, I'm going to start with this frame. I'm going to go N to apply a frame set to the a frame effect to this single frame, and we'll go with break. Okay, so there it is, and now we have this, right? Everything's bouncing off the walls, and you can see that the objects are moving right to the very boundaries of space. See, it's very close there. The next iteration of this move would be over the line, so it bounces off. See, just like that. So this thing, collectively, all the frames together, takes up pretty much 100% of this display area, or of space itself. Okay, so what we want to do for this little example is I'm going to shrink this down. So now it's significantly smaller. Okay, going to go into menu V, that's Victor or View, right? And we're at about 39% of full space. And the zoom factor is, and I'm going to apply the scale with a capital G, so it will apply the scale to all of the frames in the set. So I'm going to go Shift G, and there it's done. So now you see the boundaries of space, the floating bounds have now gone out back to normal, okay? But the art itself has now been scaled to be smaller than it was. And that's what we want, okay? So now I'm also going to offset it a little bit so it's not at the center. And we do that with Q to pan in X and W to pan in Y. So we're going to Q it over this way. Actually, let's do something real quick here. Let's go here and let's show fixed bounds. That's A. And fixed origin, that's B. Okay, so this is, okay, this is an origin which does not change when you change the view of the camera. It's always going to show you the origin of basically the space as it were normal, if it were at normal zoom and normal rotation. Okay, so we decided we're going to move things over a little bit, right? So now they're moved over, and we're going to move things up. Okay, so now this art is offset. It's not centered, right? So let's say, for example, this was an import from some other source. Maybe this didn't come from LaserBoy. Maybe this came from an ADAT recording or something, and maybe the person who made the recording didn't have their levels right, and maybe didn't have the offsets right, or whatever it was. So you got this to start with. So I'm going to go ahead and I'm going to apply here. I'm going to apply the offset to this frame with a capital T, so it does it to the whole frame set. And now we're back to normal. Zoom, no offset, no rotation. This is literally what the art looks like from the straight on view. Okay, and you can see it's all pretty much in the positive region of space. All right, it's all above the x-axis, which is all positive y, and it's all beyond on the positive side of both x and y. So everything's going on in this quadrant up here, pretty much. Okay, now with this as a starting point, I'm just going to go ahead and save this. Oops, I'm going to save this. So I'm going to go out 1 for ILDA, 1 to stay in the current directory, 3 to save the whole frame set, and we're going to call it Normalize. Oops, yeah, let's see. All right, and there, it just saved it. Okay, so now that's saved, and we can open it again for further demonstration purposes, right? So what we have here now is, like I said, it's all offset and it's kind of small, right? So if this is what we bring in, we can normalize this. If we go into menu H, we have this option 8, Normalized Vectors percent to space by itself is what it's currently set to. What that means is, if you were to look at this whole cluster of points throughout the entire frame set, there is a calculated center of this mass of points that's moving around. Even though it's an entire set of frames, the whole set of frames has a calculated center to it. So we can normalize the entire frame set to be centered upon itself, not the origin, but itself, and we can change the size of this. And when we change the size of it by normalizing it, we're not increasing or decreasing the size of this by a percentage, like we're not making it 10% bigger or 10% smaller. What we're going to do is we're going to make the size of this a relative percentage of all of space itself. So it really doesn't matter what size this is. The end result is going to be a percentage of the size of the space that it can occupy. The calculated center of this cluster of points is probably not exactly the same as this one or this one or whatever, because you see this is moving up higher and this is moving lower. So the calculated center for each frame is going to probably be unique. But the calculated center for the entire frame set, all examined together, the frame set is going to have an absolute maximum in X and Y, an absolute minimum in X and Y, and you can calculate this. LaserBoy can find the center of the entire frame set. So when we go to normalize, we'll just go Shift 8. We're here, okay, 100% of space, and here's where it asks us, do you want to normalize each frame individually? And for this part of the demonstration, I'm going to hit another key other than Y, because no, I want to normalize the entire frame set. So I hit space bar and boom, it just did it. So now you can see we're normalized at 100%. It found the center of the entire frame set, and now the frame set takes up 100% of the boundaries of space. So there's one example of how Normalize works, okay? Now, I'm going to stay in the ILDA directory. I'm going to open Normalize again for demonstration purposes. Escape. Now, we're back to where we started with this example that's offset and kind of small, okay? Now, this is the origin of space. Now, if I click on the X menu, I have this option 6 right here, Normalized Vectors to Origin in Editor, which is where we are, and in DXF Import. Well, what that means is DXF is also a vector coordinate system, and obviously it has an origin of its own. There is a point 000 in a DXF environment, and the art might be centered around the DXF origin, or it might be offset like our example is. And so when we're importing DXF files, this logic that I'm showing you here applies the same way. So I'm going to turn this on. So now we are normalizing vectors to the origin, meaning that where these things are in space right now has a relationship to this point, the origin. So in menu H, right, now it says 8, normalize vectors percentage to space with origin. Before it said with itself, now it says with origin because we changed that setting in the X menu, right? Now we're considering the origin as being an integral location in this arc. So if I normalize this, if I go Shift 8 to do, okay, it's asking me again, do I want to do it 100%? Yeah, that's fine for the purposes of this example. And again, it's asking me, do I want to normalize each frame individually, or do I want to normalize the entire frame set as a whole thing? And so I want to normalize the whole frame set. I don't want to do this individually, so you can see the effect. So I'm going to just hit the space bar because that's any other key, right? And boom, there, it did it. Now, as you can see, the art still has the same relationship that it did with the origin. It's all in the positive space quadrant, but it's enlarged to the point where it is literally going to 100% of the boundaries of the space, given that it still has the relationship to the origin. See how that works? All right. So that's an example of how things work. If you, again, I'm going to go into menu X. I'm going to turn option 6 off. So now, back in menu H, it says by itself, it's going to normalize to its calculated center of vectors. So I'm going to shift 8, 100%. Let's, just to show you how this works, let's go 70% of normal space. And no, I don't want to normalize the frames individually. I want to do the whole frame set. And boom, see, there it is. It found the center. And now the boundaries where it's bouncing, the maximum that it's going to move in X and Y and the minimum it's going to move is 70% of space, right? Regardless of what the original size of the art was, it's now 70% of the size of space. So that's one way that normalization works. All right, now another way that it works, I'll show you, I'm going to create another example here. Let's go, okay, let's go in, one for an ILDA, one to stay in this directory, and we'll open in.ild, and we'll place the current frame set, escape, and we'll go to, let's see, this frame right here, this nifty frame, right? Okay, so from here, I'm going to go into H. Well, first of all, I'll show you. This is, in fact, a 3D frame, right? But I don't want this to be 3D for this purpose, so I'm going to choose, in menu H, I'm going to choose option 1 and flatten the Z-axis, and so now you can see it's flat, okay? Now, I'm going to go into menu L. I'm going to select the whole thing. I'm going to shrink it down to where it's about that big, right? That's cool. Now, there's only so many points in this, and as you can see, I'll turn the points on. See, there's the points so you can see them. Oh, but whoops, I'll get rid of the floating bounds and fixed bounds and fixed axes. Well, we could keep the fixed bounds. That's a good thing to have on. Okay, so whoops, that's fixed axes. Fixed bounds. There we go. Right, fixed bounds is on now, and so is floating bounds. Right. So now, there's only, see how these points, they get further and further apart, right? Well, I want a lot of points here because the next thing I'm about to do, I'm going to pull colors into vector space from a bitmap. And I'll show you how that works. So I'm going to go into menu H, and first I'm going to go into the tab menu here, and I'm going to set this number, this maximum optimized lit vector in points. I'm going to set this to something a lot lower so that we get a lot more points. So I'm going to say option 3, and we'll set it to 160 points, which is quite a bit less than 800. So now escape out of there. Now I'm in menu H. If I hit S to add lit distance span, boom. See, you got tons of vertices now to work with, tons of points in space, right? Close to each other, right? So escape from here. Now, here's what I'm going to do. First, I'm going to choose N to apply a frame effect to the single frame, 1. I'm going to choose the scan effect, boom, and okay, and 400 frames, make it 600, why not? Okay, and it takes a while because there's a lot of points to move around in each frame. Well, in the frame, I should say, taking one frame and making a set of 600 frames from it by moving it around. And this is what we get. Okay, so it's got, as you can see here, we got this thing bouncing off the walls, and also it's rotating slowly as it does so. See this little end point here? See, it's spinning around counterclockwise. Okay, so that's cool. Now what we're going to do, this is kind of nifty. We're going to, okay, we're in the main menu, right? So from main, input, we're going to choose a bitmap file, 6. And option 2 here says open as frame set color map. 1 would be a single frame. 2, it opens a bitmap as a color map for the entire frame set. So that's what we're going to do, option 2. And we're going to use Tux 768, which comes with the LaserBoy distribution. And we're going to do that. Boom. There it's done. And here's what we get. Okay. That's Tux, the Linux penguin, with some artwork behind it. Okay. first frame. Now, okay, what we're going to do here is we're gonna look at what happens when you answer yes to optimizing, or excuse me, normalizing each frame independently. So, okay, again, we'll go into menu X here, and okay, currently it's not set to normalize to the origin. So let's go ahead and set that. Okay. Right. So now, when I go into menu H, option 8 says normalize vectors percent to space with origin. And as we explained that before, what exactly that means. But here's the thing. In this frame set, you see, it's hitting the walls, right? But there's all the frames in between. This object here is inner frame. It's not on the walls. So if we normalize each frame independently to the same percentage of space, let's just say in this case 100% of the size of the frame, that means that every frame, this thing here is going to be scaled so that it fills the boundaries of space. Even if it's in the center now, in this frame here, like in the very first frame, this is dead center, this is going to fill space. And this is going to fill space, and it already does because the origin is here. This is as far as you can go in space. So the effect of this is really kind of unusual and kind of cool. So we'll go into menu H, and we're going to say Shift 8 to normalize vectors percentage of space with the origin. 100% is fine. We'll go with that. And now we're going to answer yes. We do want to normalize each frame individually. So we say Y. And there, it's done. Now watch what happens. Now that's kind of weird. It's actually scaling every frame independently so that it fills the entire region of space 100%, and as you can see, it's got kind of a neat fluid motion. It's even though it's changing scale, it's changing incrementally in such a way that you get this weird effect. This is actually a really cool effect to use for like beam effect kind of thing. So that's kind of nifty. So as a matter of fact, I'll just go ahead and show you what that looks like, what I mean by that. So, okay, we're going to go the first frame. We're going to say M. We're going to, excuse me, we'll go to J. We'll go to 9. Now we have an empty frame out of here. M. Let's draw a polygon, right? D. Let's give it, let's just make a triangle, 3 sides. Boom, there we go. Escape out of here. Let's see, tab menu. I'm gonna bump this up to something like 2600, right? Escape. And H. Gonna minimize. Add lit distance. Okay, so now we've got a bunch of points, and they're separated about 2,600 points away. 2,600 coordinate locations apart from each other. So let's go into something else that's kind of nifty in menu H. We can convert the lines, these continuous lines, into dots, and that looks like that. See, now we have dots instead of a solid line. Okay, so now we're going to go into menu G, and we're going to best match to this nifty palette here. Go to the tab menu. We're going to set the W recolor palette span factor W to 1, and okay, now we're going to color this using option 5 to span the palette angularly around the origin to the art. So we hit 5, and now we get that. See, palette starts and goes all the way through there, radially around the origin. So that's kind of nifty. Okay, so now let's go into L and select the whole thing and shrink it down to about there. Okay, now I'm going to go N frame effect, and we'll go with the same effect, scan. And why not make it 1,000 frames? Boom, there it's done. So now we got this thing, right? That right there would be a pretty nifty beam effect, honestly, right? Okay, but we're going to go into menu H, and we're going to do that same thing that we just did. 8 normalized vectors percent to space with origin. Okay, so it's shift 8. 100% is fine, and we're going to answer yes. Again, I do want to normalize each frame individually. So boom, there, it's done. Now watch this. See how it's changing size as it's moving around, right? Right? That's pretty cool. Okay. Now we can even bump this up a little bit. Going to go to N to apply an effect to the entire frame set. That's option 3. And we're going to go with kaleidoscope, and we're going to do 3 reflections. Boom, it's done. That is a pretty nifty beam effect. I like how it kind of, it's jerky, but it's still fluid at the same time. That's pretty cool. Anyway, okay, back to where we were before. We're gonna demonstrate another way to normalize, this time without the origin. Okay, so we're gonna go in, we're gonna go 1, we're gonna stay in the L directory, and we're gonna bring tux back in again, replace the frame set, boom. And here we are, back to this again. Okay, so now we're going to go into the X menu, and we're going to turn this off. 6 is off. Now we're not concerned with the origin in space or preserving it in any way. So in menu H, and this is kind of cool, we're going to do shift 8, right? And we're going to do, we don't want to do 100%, okay? I want to do, let's show you something else that's kind of nifty, so I can get out of here. If you do a question mark, you get frame statistics, and the /, which is the unshifted question mark, gives you frame set statistics. Now what this says is there's 600 frames, they're all 2-dimensional. There's a total in this thing of almost 3 million vertices in the entire frame set. The frame set is, the scale of it, the size of the whole thing is very close to 100% with the origin, because of course it's bouncing off the 4 walls, so it's taking up the full amount of space that's available here, right? So it's pretty much 100%. But see this, it says 27.33% on itself, and here this individual frame is 27.08% of itself, okay? And and this particular frame is only 74% of space with the origin, because see, it's not touching the edges. So this gap here compared to the origin means that it's filling about 74% of the frame currently, if the origin is included, right? So now we know that on average we're looking at 27.33%. That is the size of this thing currently as it's bouncing around in space. Okay, that's the size of itself compared to space, right? So get rid of that, get rid of that. Okay, go back into menu H, shift 8. So here we're going to go 27.33, because I don't really want to change the size of this. I like the density of it, so we'll go with that. Right. And here we're going to answer yes, we do want to normalize each frame by itself. And here's what happens. Because we're normalizing based upon itself, it centers. No matter where it is in the frame, it finds the center of itself and puts it at the origin. And you get this effect, which I think is pretty cool. So those are some of the things you can do with normalizing it. Normalizing things. It can be just purely a utility to straighten out or some frames that you brought in from somewhere else that don't conform to being centered or being the right size. You can use it as a utility, but you can also use it to create a very interesting visual effect as well.